Testing, testing. Okay, Math 0092. We're starting with Chapter 11. And Chapter 11, we're going to be introducing ourselves to algebra. In algebra, we talk about variables. A variable can be something like your age. It can vary. We could let A equal your age, and A changes as your birth date changes from year to year. A constant, we could let B equal a constant, and that's, for example, your year of birth. It remains constant. It doesn't change. And then we look at equations, where we might have something like evaluate x plus y. And we're supposed to evaluate when x equals 37 and y equals 29. So this just means that at this point in time, our variable is going to vary, but at this point in time, x is 37. So for every occurrence of x, I'm carefully substituting 37. I'll copy everything else down the same. And for every occurrence of y, I'm going to carefully substitute 29. And then adding 37 plus 29 is 66. But think about, this was an evaluation. We sent our field rep out into the field, and they came back and collected the data that x is 37 and y is 29. And now again, last night the field rep came back and the data has changed. X is 30 and y is 30. So we're going to substitute back into our expression, substituting very carefully. For every occurrence of x, I'm going to substitute 30. And for every occurrence of y, I'm going to substitute 30. And 30 plus 30 is 60. So at this point in time, when x is 30 and y is 30, my expression evaluates to 60. We're asked to evaluate 3 times y. Now, this is 3 times y. There's no plus or division, so we understand that to mean multiplication. And we're supposed to evaluate when y equals 14. So I'm, again, my expression 3y, I'm going to very carefully copy everything down the same, but for every occurrence of y, substitute 14. And 3 times 14 on your calculator is 42. We have an rectangle whose length is equal to 24.5 inches and whose width is 16 inches. And we're supposed to calculate the area. We need to remember that area is equal to the length times the width when we're dealing with a rectangle. So we can substitute very carefully. The length is 24.5 inches times the width is 16 inches. Now remember that this is all multiplication, so I can use my commutative property. My terms can commute. So I'm just going to get my constants together and get my unit measurements together. With your calculator, 24.5 times 16 is 392, and inches times inches is inches squared. So the area of this triangle is 392 inches squared. We're asked to evaluate. And our expression is A over B when A equals 63 and B equals 9. So at this point in time, I'm going to substitute these data values in for every occurrence of A, 63, and for every occurrence of B, 9. And 9 goes into 63 7 times. Evaluate M plus N divided by 12. When M equals 8 and N equals 16. So in my expression, I'm going to let my variables take on these values. I'm going to very carefully substitute for M, 8. For every occurrence of N, I'm going to substitute 16, all divided by 12. 16 plus 8 is 24, all over 12. And 12 goes into 24 2 times. We have our multiplication identity. Remember, A times 1 is equal to 1 times A, which equals the real number itself. 1 is our identity property for multiplication. So 5 times 1 equals 1 times 5 equals 5, the number itself. Multiplicative identity property is 1. Then we introduce our distributive law. Of multiplication over addition. Distributive law of multiplication over addition, which is for any real numbers A, B, and C, A times the quantity B plus C is equal to AB plus AC. So if I have 6 times the quantity X plus Y, that's equal to, well, 6 is in the A position, so 6. B is X plus 6 again is in the A position, and C is Y. So 6X plus 6Y. Let's check this. 6 times 10 plus 5 should equal 6 times 10 plus 6 times 5. Well, this is 6 times 15, which equals 60 plus 30. And 6 times 15 is 90. And 6 plus 30 is 90. So it looks like that holds true. Let's evaluate when we have 4 times x plus y and see if that checks to 4x plus 4y. When x equals 11 and y equals 5. So now I'm asked to substitute. So I'm going to substitute, copy everything down the same, but for every occurrence of x, I'm going to substitute 11, copy everything down the same. For every occurrence of y, I'm going to substitute 5. Copy everything down the same. For every occurrence of x, I'm going to carefully substitute 11, and for every occurrence of y, I'm going to carefully substitute 5. This is 4 times parentheses 16 equals 44 plus 20. 4 times 16 is 64, and 20 plus 44 is 64. So that looks like that's holding true. Let's see what happens when we multiply. 8 times the quantity A plus 2B minus 7. This is 8 times every term within the parentheses. Well, I see subtraction. We always take care of that, so we know the sign of our term. I'm going to rewrite that as 8 times A plus 2B. Change subtraction to addition and add the opposite. This is 8 times every term within the parentheses. That's our distribution property. I'm going to distribute 8 times the first term, and I'll get 8A. Pick up your sign. And distribute 8 times the next term, which would be 16B. Pick up your sign. And 8 times the last term, that's 8 times a negative 7. It's going to be negative 56. And then write our final form, 8A plus 16B. Remember, this is subtract 56 because we change subtraction to addition and add the opposite, and we're back at this. So plus the opposite of 56 is the same as subtract 56 because we can always change subtraction to addition and add the opposite. And this is the most likely way you'll see your answers at my math lab. So just converting to a final form, it's a little cleaner and the way typically shown at my math lab. So let's look at the distributive property, 9 times the quantity x minus 5. This is 9 times every term within the parentheses. Let's rewrite this as 9 times x plus the opposite of 5. Now we'll use our distributive property. 9 times the first term would be 9x. Pick up your sign. And 9 times a negative 5 would be a negative 45. And then rearrange, clean it up, make your answer a little neater. 9x minus 45. 2/3 times the quantity w plus 1. Well, this is the distributive property. I'm distributing something times every term within the grouping. So I have 2/3 times w, pick up your sign, and 2/3 times the next term. 2/3 times 1 is 2/3. Factoring. Factor. Factor is to find an equivalent, something that's equal, expression as a product. Now, product means our answer when we multiply. So you're asked to factor 5x minus 10. Factor means to find an equivalent expression as a product. So I want to find something equal, but as a product, which is something times something. Well, I see that I have a common factor of 5 in each term. So I can bring out my common factor, 5, and use my distributive property. 5 times what would give me 5x? That'd be x. Pick up your sign. And 5 times what would give me 10? That'd be 2. Let's check. 5 times x minus 2. Distributive property, 5 times x would be 5x. Pick up your sign. And 5 times 2 is 10. And sure enough, so you can circle your answer. Now notice here I have sums and or differences of terms. This is a product. It is an equivalent expression as a product. That is something times something. Something times this entire grouping. You're asked to factor. 9x plus 27y minus 9. Factors means that I need to have an equivalent, equal product, something times something. So I see I have a greatest common factor of 9. I'm I'm going to factor that out and use my distributive property. 9 times what would give me the first term, 9x? Pick up your sign. 9 times what would give me 27y? 27y would be 3y. And distribute 9 times the last term would give you, pick up your sign, 9 times what would give you 9? That'd be 1. So 9, and we can check, 9 times x plus 3y minus 1. 9 times x would be 9x, pick up your sign. 9 times the next term would be 27y, pick up your sign. And 9 times the last term is 9. 9x plus 27y minus 9. Sure enough, that checks. So now we have written an equivalent factored, something times something. An equivalent expression factored. We're supposed to factor. And we're given negative 3x plus 6y minus 9z. We're supposed to factor that. Well, let's change subtraction to addition and add the opposite. So I have a negative 3x plus 6y. Here's subtraction. Change subtraction to addition and add the opposite. Now, is there a greatest common factor in each term? We can factor out a negative 3. Negative 3. Negative 3 times what would give you a negative 3x? Positive x. A negative 3 times what would give you 6y? A negative 3 times what would give you 6y? That'd be a negative 2y. Pick up your sign. And a negative 3 times what would give us a negative 9z? That'd be 3z. A negative 3 times a positive 9, 3 would give us a negative 9z. Well, let's clean this up a little bit. Negative 3 times the quantity x minus 2y plus 3z. Let's check. Negative 3 times the quantity x minus 2y plus 3z. This is distributive, so 3 times the first term is a negative 3x. Pick up your sign. A negative 3 times 2y would be a negative 6y. Pick up your sign. And a negative 3 times 3z would be a negative 9z. Let's clean this up a little bit. Negative 3x. Change subtraction to addition, add the opposite. The opposite of negative 6y is positive 6y. And then we would rewrite this for my math lab. 9z, subtract 9z. Remember, we can always change subtraction to addition and add the opposite. This is the same. So negative 3x plus 6y minus 9z. We can circle our factored answer. Something times something times something. Factoring by looking for the greatest common factor in all terms. Collect like terms. Well, like terms have the same variables to the same degree. So this term has x to the first degree. This term has x to the first degree. They are like terms. 3y squared and 9y squared. This term has a y squared term. This squared term has a y squared term. They are like terms. 5xy and 4x are not like terms. I have a 5x, but here's also a y. So this term is not a like term to 4x. We like terms have the same variables to the same degree. So we can collect like terms like 4x plus 6x. These are like terms, x, variables are the same to the same degree. So I actually have 10x. 2x plus 3y minus 5x minus 2y. I see subtraction here, so I'm going to rewrite this. Change subtraction to addition and add the opposite. Change subtraction to addition and add the opposite. Now I can collect like terms. I have x to the first degree and an x to the first degree. 2x plus a negative 5x would be a negative 3x. And look at my y terms. Here's y to the first degree and here's y to the first degree. I can collect them as like terms. 3y plus a negative 2y would be a positive y. I have collected like terms to simplify. 3x minus x. That's 3x. Change subtraction to addition and add the opposite. I do have like terms. This is x to the first degree, x to the first degree. 3x subtract 1x would be 2x. X subtract 0.24x. Well, I see subtraction, so x, change subtraction to addition and add the opposite. This is actually 1.0x plus a negative 0.24x. And 1 subtract 0.24 would leave us with a positive 0.76x. X to the first degree, x to the first degree, I can collect like terms. X minus 6x. Again, x subtract, I'm going to change subtraction to addition and add the opposite. I do have like terms. Negative 6x plus 1x would be a negative 5x. Collecting like terms. 4x minus 7y plus 9x minus 5 plus 3y minus 8. I see some subtraction. We always take care of that so we know the sign of our term. 4x, change subtraction to addition and add the opposite. Plus 9x. Change subtraction to addition and add the opposite. So now I know the sign of the term. Plus 3y and change subtraction to addition and add the opposite. Now I know the sign of all of my terms. Let's see if there's any other 4 x's that I can collect. There's x to the first degree, x to the first degree. 4x plus 9x would be 13x. Looking at my y to the first degree terms, a negative 7y plus a positive 3y would be a negative 4y. And then I have my constant terms. A negative 5 plus a negative 8 would be a negative 13. And let's write our final answer form. 13x. Remember, we changed subtraction to addition and add the opposite. I can change to subtraction then. Subtract 4y, change subtraction to addition and add the opposite, so I can change that back to subtraction. 13x minus 4y minus 13. Collecting like terms. We're asked to collect like terms. 2/3 a subtract b plus 4/5 a minus, or plus 1/4 b minus 10. Well, I see subtraction, so I'm always going to take care of that. 2/3 A. Change subtraction to addition, add the opposite. Plus 4/5 times A plus 1/4 times B. Change subtraction to addition and add the opposite. Now I know the signs of my terms, so I can collect like terms. I have an A term. Here's an A term. Collecting, I have 2/3 A plus 4/5 A. My B terms, B to the first degree, I have a negative B plus a 1/4 B. And constants, I have a constant term of a negative 10. Well, to add fractions, we need to have a common denominator. 3 and 5, that'd be 15. So we'll convert 2/3 A to 15th. So I'll need to multiply by 5 in the numerator and the denominator. Plus 4/5 A. And I want to multiply by 3 in the numerator and the denominator. Plus, this is actually a negative 4/4B to get a common denominator of fourths. And I have my constant 10. So here I have 10 times 2 is, or 5 times 2 is 10 times A over 15. 12A over 15 plus, this is all over 4. So I have a negative 4B plus 1B all over 4 plus a negative 10. Now this is my common denominator 15, 10A plus 12A all over 15 plus a negative 4B plus 1B would be a negative 3B over 4. And this is plus a negative 10. Here I get a 22A all over 15. This is plus the opposite, so it's subtract 3/4 B. And this is plus the opposite, so it's subtract 10. This is 11.2, and it begins on page 655. We're looking at equations now. We are seeing the equal sign, not just an expression. We're seeing the equal sign. And for any real numbers A, B, and C, if A equals B, then that's equivalent to A plus C equals B plus C. And what I want you to notice is that we know A equals B, but if I add C to one side of the equation, I have to add C to the other side of the equation to keep my pendulum balanced. A equals B, then A plus something is equal to B plus the same thing. So if you think of a pendulum and a weight, we're adding C to one side of the equation. We have to keep it balanced by adding C to the other side of the equation. And this is called our addition principle. And we use this addition principle to solve equations. So we're asked to solve for x. We're given x plus 6 equals 13. We're supposed to solve for x. So this may be mental math for you, but we are applying the theory now. So we want to practice the theory. I'm supposed to solve for x, which means our goal is x equals something. We're solving for x. So I want to be able to say x equals. Well, if I use my addition principle, I can add the opposite of 6 to both sides. I'm choosing to add the opposite because 6 plus its opposite goes to 0, and x plus 0 is x equals. So that's my strategy. I applied the addition principle by adding the opposite, isolating x, so now I have x equals. But I'll have to tidy up the other side of the equation. 13 subtract 6 would be 7. Let's check. X plus 6 equals 13. And our answer is, we're going to substitute x equals 7. So for every occurrence of x, I'm going to substitute 7. X 7 plus 6 is 13. That equals 13. So sure enough, your answer is correct. X plus 5 equals 9. We're asked to solve. That's all your directions say, which means our goal in this case is x equals again. We want to be able to isolate x. So I'm going to use my addition principle to isolate x by adding the opposite of 5 to both sides. I'm adding the opposite because x plus 0 is x equals, which gets me very close to my goal, but I need to tidy up this side of the equation. 9 plus a negative 5 would be a positive 4. Let's check. X plus 5 equals 9. We're going to substitute our answer, x equals 4, and for every occurrence of x, 9 equals 9. Sure enough, we can circle our answer. Solve y plus 15 equals 24. Y plus 15 equals 24. I'm going to use my addition principle because I want to set a goal of y equals, in this case. I want to isolate and solve for y. I'm going to add the opposite of 15 to both sides. The opposite of 15 plus 15 goes to 0, so I have y equals 24 minus 15 is 9. And you can check. Negative 6.5 equals y minus 8.4. We're supposed to solve. Y is my variable in this case, so I have a goal of y equals. I'm solving for y, and I want to isolate y. I'm going to rewrite this. Y subtraction changes to addition, and I add the opposite, so I know the sign of this term. And I'll use the addition principle to add the opposite, which is a positive 8.4. But if I add 8.4 to this side of the equation, I'll have to add 8.4 to this side of the equation. Adding opposites goes to 0. Y plus 0 does equal y. So I'm getting close to my goal. 8.4 subtract 6.5. 8.4 subtract 6.5 is 1.9. Check. Negative 6.5 equals y minus 8.4. Negative 6.5 equals, we're going to substitute 1.9 in for every occurrence of y. 8.4, change subtraction to addition and add the opposite. Subtract 1.9 from 8.4. And we'll get 6.5. And then we're going to keep the sign of the absolute value, which is larger, which is negative. Negative 6.5 equals negative 6.5. This is mechanical. I know some of these are probably mental math for you, but we're establishing the theory of applying the addition principle. Now if A equals B, then B equals A. Equals are equal to each other. We're supposed to solve, so in this case our goal is T equals. We have a variable of T. So I could rewrite this as T plus 4 equals a negative 22. I just switched sides. Negative 22 equals T plus 4, then T plus 4 equals negative 22. Getting my variable on the left-hand side of the equal sign is comfortable for me. So now I'm going to use my addition principle. I'm going to add the opposite to both sides. Isolating T equals a negative 22 plus a negative 4 would be a negative 26. X minus 7 equals negative 21. Our goal is to solve for x. So we want to be able to say x equals. I'm going to rewrite this. X plus the opposite of 7 equals negative 21. So I know the sign of my term. Then applying the addition principle, I'm going to add the opposite, which is 7, to both sides. Adding opposites goes to 0. X equals a negative 21 plus 7 would be a negative 14. R plus 1/3 equals 8/3. Our goal in this case is going to be able to solve for R equals. I'm going to use my addition principle so I can isolate R. I'm adding 1/3, so I'm going to subtract 1/3. I'm adding the opposite, goes to 0, so R equals 8/3 subtract 1/3 would be 7/3. X minus 5/6 equals 7/8. We're supposed to solve. My goal is to isolate the variable x equals. I see subtraction, so I always change subtraction to addition and add the opposite so I know the sign of my terms. If I add the opposite of 5/6, I'll be using the addition principle, and I'm going to add positive 5/6 to both sides. Now I'm adding opposites, which goes to 0. X plus 0 is x equals. I'm getting pretty close to my goal. I just need to tidy up this side of the equation, and I have 7/8 plus 5/6. Now we're back to adding fractions or subtracting fractions. We need to think about the piece of pie. We need a least common denominator. 8 goes into 24 and 6 goes into 24. So let's use least common denominator 24. We're going to convert eighths to 24s. So I have 7/8. 8 times 3. Multiply the numerator and the denominator by 3. Plus, we're going to convert 5/6 to 24s. 6 times 4 would be 24. So I'll multiply the numerator and the denominator by 4 as another name for 1. I'm not changing the value of these fractions. I'm just converting to its equivalency in 24s. 3 times 7 is 21 over 24. Plus 4 times 5 is 20 over 24. I now have a common denominator, so I can add my numerators all over 24. X equals 41 over 24. 41 is prime, so I can't simplify that any further. 11.3. We're going to introduce the multiplication principle. Page 659. For any real numbers a, b, and c where c is not equal to 0, if a equals b, then that is equivalent to a times c equals b times c. Notice that if a equals b and I multiply both sides by c, I maintain the equivalency. We sometimes say multiply both sides of the equation by the same number, and we still maintain the identity. So I have 5x equals 70, and I'm supposed to solve. So again, my goal is going to be x equals. We're solving for x. This time I see that x is tied up in multiplication. It's 5 times x, and I'm solving for x, not 5 times x. So I'm going to use my multiplication principle, and I'm going to multiply by the reciprocal of the coefficient on the x term. The coefficient 5's reciprocal is 1 over 5. But if I multiply this side of the equation by 1/5, because of some strategy, I need to multiply the other side of the equation by the same thing. Now, I chose to multiply by the reciprocal because a number times its reciprocal goes to 1. And 1 times x is x equals. I'm getting close to my goal. But I have to tidy up this side of the equation. Now, 5 goes into 70 14 times. You can check. 5 times 14 equals 70. The multiplication principle. 3/8 equals a negative 5/4 x. I want to solve, so my goal is x equals. This is a negative 5/4 times x, so it's multiplication. I'll use the multiplication principle. I know that if I multiply by the reciprocal, a number times its reciprocal is equal to 1. So I'm going to choose to multiply this side of the equation by the reciprocal of the coefficient on x, which is flip it and keep the sign. But if I multiply by the reciprocal on this side of the equation because of some strategy, I'll have to multiply by the reciprocal on this side of the equation to maintain my equivalency. Multiplication of fractions is a piece of cake. A negative 4 times 3 is a negative 12, and 5 times 8 is 40. A number times its reciprocal goes to 1, and 1 times x is x. So I'm getting close to x equals. Let's see, 2, how about 4? 4 goes into 12, a negative 3 times, and 4 goes into 40 10 times. So x equals a negative 3/10. $1.16y equals 9744. We're supposed to solve. So my goal is going to be y equals. I want to isolate the variable. And I see that this is 1.16 times y. So I'm going to use my multiplication principle. I'm going to multiply by the reciprocal on the variable coefficient. The reciprocal of 1.16 is 1 over 1.16. But if I multiply by the reciprocal on this side of the equation because of some strategy, I'm going to have to multiply it by the same thing on this side of the equation to keep and maintain the equivalency. Now our strategy was to multiply a number by its reciprocal because that goes to 1, and 1 times y would be y equals. I'm getting close to my goal, but I need to tidy up this side of the equation. And now perhaps you can see why it's so important to learn the theory of the addition principle and the multiplication principle, because this is probably not mental math. So I have 9744 divided by 1.16, which is 8,400. So y equals 8,400. And you can check. The addition and the multiplicative principles used in solving equations in algebra. Negative y over 9 equals 14. We're supposed to solve. So our goal is y equals. Well, let's just look at this a little bit. This is actually a negative 1/9 times y equals 14. So I have something times y. I'm going to use a multiplication principle to unwrap y. I'm going to multiply by the reciprocal of the coefficient on the y term. Now the reciprocal of negative 1/9 is flip it and keep the sign. So my reciprocal is negative 9 over 1. I'll need to multiply by the same thing on this side of the equation. A number times its reciprocal goes to 1. 1 times y is y equals. That's good. I'm getting close to my goal. But now I have to take care of this side of the equation. And 14 times a negative 9 is a negative 126. So we want to practice applying the addition principle. When you have an equation, whenever you add something to one side of the equation, you have to add the same thing to the other side of the equation. And the multiplication principle. Whenever you multiply by one value on one side of the equation, you have to multiply by the same value on the other side of the equation as a means for strategies to solve for equations in algebra. All right, return to D2L Brightspace for your details regarding homework, assignments, tests, and due dates. And thank you very much.